Hi, it's Gadget UK here again, looking at a HDMI video converter here. It's got a bit of a dint in the top there. Came from Jamie Morgan, he sent me a few of these. I looked at one of these before, like years and years and years ago, for Scott, console snob. I can't really, he changed his name, didn't he? I'll stick his name top left. But anyway, yeah, that one, I just salvaged the parts off it. It was completely toast. I think the main chip had died on it. I didn't do a video on it, I should have done. But we've got two of these here now, so I'm going to be able to show you exactly what we covered before, really. It might be the same fault with both. So we've got power, 5 volts to centre, positive. Just using the Mister power supply here. Got HDMI out to the TV here. Now you don't actually need a source connector at this point. You would usually see something on the screen saying what frequency it's at, etc. But we get nothing. I never pressed the buttons on it. Nothing at all. So it would seem to be completely dead. So let's take the screws out. And these things are, you know, recipe for failing really, because it's a nice metal case, but it's solid. There's no air gaps or anything. They overheat, and I'm sure they all ultimately die this way. I do have one of these myself, actually. I have one of these myself in the other room. So, from memory, I think there's one screw here, isn't there? Let's get that out. Yeah, I'll move the Mister off the bench in a sec. I think there's the one screw, and then I think, doesn't this slide out or something? I honestly can't remember. It's that long ago since I looked at Scott's. I think it does, yeah, it slides like that, and then that comes off. So we can certainly test it with the lid off. I'm just going to inspect around there, just see if we can see anything obvious. Yeah, there's a couple of little regulators down there. We've got an AMS 1117 1.8, so 1.8 volt regulator. The solder points look awful on that. And one next to it, which is, can't see actually, it's probably a 3.3. Yeah, the caps look alright and stuff, and I don't see anything obviously faulty on it. Yeah, I'm just going to move the Mister off the bench, and then we'll connect up power and HDMI again. Right, let's connect HDMI up again. So, I forget which one's output now, that's input. Output is round here. Yeah, looking at the HDMI connections, they look alright. It feels a bit fluffy, that. So you never know, it could be a HDMI connection, but I doubt it. Just moving that around, it's not affecting the signal on the TV. So I'm just going to measure those two regulators, I think. If I go from a ground, I know that that's ground, to, I think the tabs on these, that's 1.8 regulator, and it's 1.78. 1.79 rather, and the 3.3 is 3.28. So the voltages are there, it's not a power issue. Just going to press down on these chips here. Not affecting anything at all. Got the wrist strap on, by the way. It's yeah, probably a lost cause this. I can measure. See, the thing is, you could measure here, you could measure there and that, hang on. But if there was no voltage getting from the power jack here through things like that inductor, you would. Hang on, it's not showing anything, that. Yeah, I'm quite surprised at that. Just put that on continuity, just disconnect power a sec. Just check that. No, that's alright. I wonder if there's any fuse type components on this. Yeah, just having a feel around really and a press around. Watching the display to see if anything changes at all. Yeah, the TV's just gone into power save. So measuring from the USB ground there, that is a ground. So the tabs on the two regulators here, I'll show you where those are in a minute, hang on. First one there, can you see 1.8 volts? The 1.8 volts regulator is fine. And 3.3 volts, 3.3 volts, there, fine. That's the 3.3, that's the 1.8. So we've got a silicon, what's it called? Silicon graphics, is it? Silicon image or something. Silicon image chip there, that's the HDMI chip, you know, a retimer or whatever you want to call it. Something similar. QFN solder around there. I might reflow that. Some of the solder points don't look good. We've got a main custom, you know, an MCU or something there, and it's probably not an MCU. It probably contains an MCU. or may contain an MCU, but it's the video processing chip, you know, so it's some off-the-shelf chip you can get for handling old standard definition video signals and things, and outputting in a digital format. And then this is obviously giving us the HDMI. We've got a crystal here, can scope that in a minute, a couple of transistors. The stuff down here is going to be for this, yeah, these passives and things are going to be for the SCART connector, power, another little regulator there. Let's just measure what that is. I think it's a regulator. It's a little 5-pin device, can you see that? It's next to this, but that might be generating the supply to these, actually, like a higher voltage. We can measure what's there, actually. Let's just do that. If I measure the, I forget which pin it is it the third pin is the input? 5 volts. 5 volts. So this here may be producing 5 volts for these, or something like that. You know, the power regulation here is stepping down to 5 for these. I've got the HDMI connected, no HDMI. We can obviously inspect the inside of the HDMI port there, that's the output, and the solder points there. If you think you've got a solder point problem, you can obviously, with a wrist strap on, just gently press with your nail on the connections, just to make sure you've not got a loose connection. Sometimes just pressing around on things can stimulate, but I'm not seeing any change at all, so this is completely dead as things stand. We'll check that crystal next, I think. It's the sort of thing, because this is a portable device, you drop this on the floor, impacts can crack crystals. You never know, crystal might go on it, but, well, I think it's unlikely. We'll scope it anyway. And as I was saying, inspect your HDMI connections in here, you know, use magnification, and just inspect to make sure you've not got any mangled pins, corrosion, that sort of thing. Those look good as new, as I imagine they would do, on the underside and the top side. We can, just for good measure, get some contact cleaner in there. Yeah, way too much. And then just insert, remove a few times, then connect power and just see if it's any different. I mean, it's not a very tight socket, that, if I'm honest. It feels a wee bit spongy. Just connect power again. Yeah, nothing on the display. Sometimes just easing it in and out, if there's a problem there, may reveal something, but I'm not seeing anything. And again, just a little bit of, you know, sort of raise it slightly, lower it slightly, not too much, because you don't want to damage and deform the socket. Yeah, I'm convinced the HDMI connector there is alright, it's just not the problem. Yeah, so connecting the scope up here, it's going to be the common ground, isn't it? And I've got a different power supply. Not that I need a different power supply. And if we scope the crystal there, yeah, I'll show you that again, just probing the right hand crystal point there. 24 megahertz, so the crystal's oscillating correctly. I'm just looking around the board, I don't see any other crystals on this. So, yeah, it's not a problem with that crystal. And this is the thing about just checking the basics, really. Voltages and clocks. The voltages are there. The clock from that is there. There could be other places clocks are missing. There could be other places voltages are missing. I don't think so. I think that it's only going to use 3.3, 5 and 1.8. Those are on the board. What else have you got? Not a lot. You've got a little device here and you've got a device there. I think that's a flash ROM, like a serial flash ROM, hence the few pins on it. Yeah, it is an XT2532B, I think, -S. So, you know, there's a chance it lost its firmware at some point. A voltage problem can sometimes cause flash chips like that to suddenly go, hang on a minute, I'm erased, I don't know anything. So you never know, it could have lost that. Well, we can't write that back. I doubt you can even read those. They're probably protected. So even if we got one of these that's working, we might have a problem trying to do anything with that. And then the chip down here, U14, Well, I can't read that at all. We'll use the microscope to check that, I think. Yeah, so that's definitely a flash ROM. There's that main chip there. That could be a fault. It could just have a bad solder point. I don't know. I don't think so, though. I may just try reflowing some of these things, but I would start with that chip there. If you look, hang on, let's just try and get the focus a little bit as it's tilted upwards. Yeah, if you look at one or two of the solder points here, and those are grounds there. Rotate it at that angle. See that? It doesn't look so clever, does it? It looks a wee bit fluffy, if you ask me. So it could be a bad solder point, but I actually think something is dead on this. And obviously, using this, the microscope here, we can zoom in a little bit. And maybe I'll do this. I won't show you everything. I'm just going to just zoom around the board, like literally zoom in and scan around the board, and just look for anything that looks clearly balked. You know, we might have something here that's got a bad solder point, but well, it's not the HDMI port, but it could be, you know, something around there. And I'll check out all these little SMD components. If we see any ferrites and 0 ohm links, we should measure those. Hang on, I've got to go right down here. So these are the regulators. Looking alright. That's that. Going back this way. Power input stuff. Yeah, so like that there, I think, is potentially giving us 5 volts from the input here. Yeah, and it's, I think that's what that's obviously filtering power. That might be a buck converter or something, I don't know, it's possible. Transistors. Yeah, and then we got that large chip there. Yeah, and obviously, you know, you could inspect these things and have a bit of a press. You know, some of these don't look so hot, do they? Might be worth reflowing that, you know. They look weird, don't they? They look like slanted to the right. That's a mysterious one. Yeah, they're definitely soldered alright. Well, at a glance, you'd need to go along and check them all, really. Yeah, here's that other IC. 0 ohm links, look, those can burn out. Bit of discoloration there, I think that's just flux. So what actually is that? Can't read the first digit. Does it say S8S003F? Gorka. Don't know. Apologies, it's very bouncy. Yeah, if we look at the location of that, where is that? That might be something to do with audio, now I think about it. I don't know, it might not be. Got the HDMI port there for the input. What's that white mark down there? Just silk screen, maybe. Yeah, there's very little to actually check. It is worth checking every 0 ohm link you see. Sometimes they can look alright, and resistors as well. Yeah, things can look alright. I think that's like 100k, isn't it, or something like that. Just looking for any more 0 ohm. Yeah, that doesn't look, hang on, where's that gone now? Yeah, that looks a bit weird there. It's alright, that measures 75 ohms, just looking at all these here. Let's go over to the HDMI bit. Oh, I got another 0 ohm there. 2 more 0 ohms there. Ferrite bead. More ferrites, I think. Wow, it's like trying to get onto that one. It's just the angle I'm at. Oh god, I can't get onto that. Yeah, that's alright. Another 0 ohm there. Probably the power going in, I would think, based on where that is. Another ferrite here. Seemingly nothing obvious. It's got to be one of those chips that's died, hasn't it? See, they lost its code. Those are 100 ohms. And they're just coming from, you know, going to here, the HDMI. I can't imagine that being a problem, to be honest. Yeah, marks from manufacturer there, look. Oh, they look shocking. It's like there's something there, like, feels like it could almost be joined, I don't know. A scratch across that. It's going to the HDMI output though, so yeah, I think unlikely. We checked those ones already going to this little chip here, I'm pretty sure we did. Problem is you rotate the board, you forget what you've done and what you haven't if you're not careful. Yeah, anyway, I may start by just reflowing this QFN HDMI chip here, this silicon image chip. The fact we're getting no HDMI output, my guess is might be that's faulty if we're really lucky. So I may order one of these and try and swap that out. Yeah, looking on the underside here, the solder points, every other solder point on, on these things here have been missed, lazy. They didn't want to use the solder look and didn't want to waste the time. So those might benefit from being resoldered, but anyway, it was held in with 3 screws. The thing that kills these is the heat. You know, it's enclosed in this metal can here. There's no circulation for air. There's no fan. They just bake. They're really cheap things, and it's the sort of thing you leave it under your table, plugged in, and you're going to forget it's switched on. We've got this awful Chong X caps on there. Yeah, I mean, there's a potential one of those caps could be a problem, but I think they're going to be on the supply rails, that's all. I seriously doubt it's one of those. My guess is this, that, lost the code. We don't know what that is. The fact we're getting no display could just be this, but if that was balked, it might not be outputting anything anyway. I wonder if you can get those. I might have a look. It might be something that it's going to need the code on that. But then again, if this chip's faulty and the code's still there, swapping that might fix it, or swapping that might fix it. So I'll investigate those 2 ICs and see if we can replace either of them. Anyway, I'll inspect around that next, that QFN chip there, to see if any of the solder points look really bad. If they are bad, I may just reflow around it and give it a try. I may then reflow around that and give it a try before I order any parts, just in case. But when you get bad solder points, just pressing like this with you, use a wrist strap obviously, pressing like this down here, if there was a loose point, you may find it suddenly sprang to life. But, well, it doesn't seem like it's a loose point, if I'm honest. Yeah, they look really dull. The solder point is bang on the side, corrosion looking as well, that top left, that top right side there. Yeah, they look awful. So you never know. I mean, it might have caused it to fail, so I might need to replace it. Yeah, they don't look great, do they? And the final side, yeah, the ground's there. One of them looks like it's barely connected, I don't know. You may think there's pins coming out of that. They're not, it's QFN. I'm sure it is. Maybe it's not. It is quad flat pack. I don't think it is though. I think I looked up the chip on eBay and it's a QFN device. If we have a look around the large chip here. Again, they don't look so hot, do they? The solder's quite wide in places. There's a blob right up the top there. If we look around this side here, it's a similar kind of thing. They don't look great. It's going to be soldered with lead-free solder as well. I mean, I would say they all look connected. They do. You can check that little flash ROM, wherever that's gone. You get a bad connection on a flash ROM, it's not going to boot, is it? Because you've got no code. And the solder points on that little IC there, whatever that is. Yeah, they look okay. Yeah, so I'm going to do them in logical order, really. The most obvious one first, which is this one, I think, just because, well, it looks the worst. I don't really like the grounds there. Those were the things I was questioning right from the start on this. And to that end, I think I'll just touch those two if I can. Assuming it's a ground. Yeah, they're joined together anyway, so do you know what? It doesn't matter if that's bridges. They both go to the same place. Let's give it a try. I can't imagine it's going to have made any difference anyway. Let's try and remember where HDMI is now. Yeah, that's the input. The output's on the same side as the power. So we've got HDMI, let's go power, see if it does anything different. Nope, it's not getting hot. Worth pressing the buttons as well, I've done that a few times. One of them swaps the HDMI mode. Not doing anything. Nothing getting hot either. You can try holding those buttons down when I plug it in. Sometimes it may seem crazy, sometimes doing things like I can like reset, or you may like, I don't know, reset the firmware or something. When I say reset the firmware, not like erase it, I'm talking about just holding a button down. May have been designed into this to just reset the settings or something, like default it. You know, it's like the more I think about this, I think the most common issue with this is going to be the actual flash ROM. And you may think, well, how would that be the case? And I remember that, I think the way these work is it remembers the setting you add it on. So if you put HDMI 720p, blah, 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 and then you unplug it, and then you come a few days later to plug it back in, doesn't it default to the same thing you left it on? Which means something somewhere is going to be occasionally writing to that flash ROM, a certain location in it. And with things like that, when power goes wrong, when something goes wrong, it can write to the wrong place in that. And then the actual firmware that maybe is used for this gets corrupted. That's what I wonder. So it could be a lost cause, this, because it could just literally be the code's not right. The only way we'd prove that is finding another one of these that's working and transplanting the flash ROM there. I mean, I've got one of these myself, but I think they vary you know, we've got another one here from Jamie. We'll have a look at that one next, I think. See if that's got anything different going on with it. Because if one of them works, I might be able to take this chip off, try and dump it, see if we can flash the other chip. That might bring this one back to life, if it is that on this one. Anyway, let's move on to the other one, because we've got no clues with that, none. We just know that it doesn't do anything. So this looks identical, doesn't it? It's got all of the same things in the same places, but will it have the same board? Will it have the same chips? How do you even get into this? One there. God, Bennett, that's well and truly stuck on. That's it. So that's the lid off that. Look, there's a blob of solder. You see that? A round blob of solder that's been floating inside this one. It's the same thing there. It's got a mysterious thing on top of the chip. Has it been milled off? It has. They've milled it off. They've milled off the top of that chip. Like, we don't want anyone knowing what that chip is. Well, tough crap. We know what it is because it's on that one. I can't believe they would do that. Yeah, they've brought a milling machine down and gone into the centre and gone milled down by about a quarter of a millimetre. Let me show you in the microscope, and I'll show you that blob of solder. I need to zoom right back out there because we're so close. We could see bacteria at that magnification. There's the solder particle. That was floating around inside it. It's quite big. So, yeah, well, that's probably caused a problem with this. And if we have a look at the top of this, where's it gone now? Look at that. Can you see? You might be able to see it's indented. They've ground the top off. So, just for the record, that's that chip. Anyone wants to know what that chip is and yours is ground off? That's what it is. Anyway, let's have a look around this one then. Solder points look a lot better on this one. I think. What's interesting about this is I think they're cloning each other, because if you look at the silk screen here, look how small the... Hang on, there is a difference actually. There is a difference. Look at the layout here, right? So we've got 4 pins down, 4 pins down, and on this one here, we've got 4 pins across at this point here. We don't have the pins down. We've got an area for a cap. There is a difference. Yeah, if I put these side by side like that, you can see, if you look at this area up here, they're different. But the general layout is the same. Everything else is more or less in the same places. It's just this side here that's different between them. Very interesting. You know, that's where the revisions have happened around up here. Anyway, let's see what this one's doing. Anyway, let's try this one then. So it goes the same way as the power, doesn't it? This the output. Hang on. Oh, no, it doesn't. That's the HDMI input. I need to retest that again. No, I'm sure I was testing it the right way. The HDMI output is on the side next to the HDMI chip there. Now let's connect power and see what happens. LED on, nothing on the TV. Again, nothing getting hot. So it's exactly the same as the other one. Button's doing nothing. Strange, isn't it? I think these have got exactly the same fault, you know. So, yeah, you can't see the meter, but I'm just going to measure the voltages here again. Got 1.8, got 3.3, so, yeah, same fault. And actually, I may have found a fault on these. I was re-inspecting this little device here, looking at this book. You know, I think this is like sort of book converter or something, some sort of voltage supply, you know, voltage regulator. Because if I measure from ground, so see here, I'm expecting a voltage here, look, and 0 volts, and over this side here, be careful not to short it, 0 volts, yeah, this pin here, 0 volts, this pin here, 5 volts. I actually think this is bogus. I was looking at the flux, I think that's been replaced. I think that's been replaced previously. Yeah, I think that's the issue. So let's zoom in on that. I'm just going to look up the data sheet for that. Maybe both of these have got exactly the same problem, and it's about the voltage regulator there. Let's just get the power. Just to flip that around. yeah, all this guesswork, and we're back to voltages. I have missed something potentially, and it could be that. So that's the TD6810. We're going to take a photo of that. Yeah, here we go. It's a voltage regulator. Hang on. 2.5 volt to 5 volt. Hang on. It's not clear what it is. Monolithic, synchronous buck regulator using constant frequency, current mode architecture, device, blah 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 blah. And fixed output ranges 1.5 and 1.8 volts. That's the fault. That is the fault. I'll check the other one now just to see if we've got the same issue, that we're not getting any voltage on the choke there. Let's do that. But if that is the case, I'm going to order some of those up. And, you know, the issue is, it's a bit like the OSSC, this. I mean, look how piddlingly weedy these things are. It's tiny. It's like, no wonder those fail. Alright, it's a buck converter. They don't exactly get hot. Point is, it's tiny. It's a piddling thing. So it could be another one of these like the OSSC, where on paper it looks like it should be up to the job, but in practice it's too tiny to survive for any period of time. We might find the opposite on this one. This one might actually have a voltage here. No, we've got nothing there. Nothing. How could there be no volts? I actually think if that was working, it wouldn't be 0 volts there. I could measure across it. Let's measure the potential across that. Probably going to kill something doing this. No, 0 volts. So there's no potential across it. There's no potential from ground to either side of it. Yeah, I'm calling it. I'm saying that's bugged. It's another one of those that's mysterious as well, in the sense that it's like that other one a little bit. It's fluxy. I don't think you can... maybe it's not. Yeah, the other one's fluxy, this one isn't. Anyway, now I know what that is, and this is the handy thing with having two of these. I wouldn't have no clue what A19C is. At least on the other one we saw it's got a really clear, readable part number, isn't it? So this is the benefit of, you know, on this one we can't see the part numbers on the chips here, but we can see the part number on that there. So between the two of these from Jamie, we'll have a clear understanding of every single part on there, what they all are. Just looking at the data sheet here, there's an example schematic. Yeah, so it's, you know, a buck converter. You feed up to 5.5 volts in, between 2.5 to 5.5 volts. So the enable in the example is joined to the V in. I'm guessing they're probably going to have done the same on this. There's a chance it's not enabled. Yeah, so in other words, it might be about firmware. It might be about the main chips on here not even enabling this because there's a problem. But let's just rule all that out. We see no voltage on here, do we? Let's just force a voltage in. So looking on the output side here, there's a feedback loop, and obviously you can maybe tailor this to dictate what voltage you get out. Let's assume it's going to be between 1.2 volts and 1.8 volts, and it might be a separate power for this. Yeah, in other words, the HDMI out. For all we know, this is actually working. It's just not outputting any HDMI because this hasn't got a voltage. We could look at the data sheet of that and work out where it gets its supply. I'm just not going to ignore all that. I'm going to throw caution to the wind. I'm going to feed 1.2 volts in initially. And where do we feed it? Well, if you look at an example schematic here, we've got an inductor. Well, we know we have an inductor. That's where I was probing here, going, there should be something there. We're getting no voltage anywhere in relation to that. So the side that comes away from the little device, the right-hand side, let's just feed 1.2 volts in there. See, does it work? If it doesn't, increase it to 1.8 volts, current limits it, and test it again. If we suddenly start getting HDMI output and the whole thing's working, we know it's just this little turd here. So let's switch the bench power supply from Ian Scott Johnson on. Let's get ready to blow something up. Hang on. Yeah, expect flames. Hopefully not. I'm going to just test connectivity here to try and find a quick, easy ground for me, so that I don't have to solder wires on. Let's test from there to there. Yeah, that's ground. So let's ground that. And set the bench power supply to 1.2 volts. I suspect it's going to be 1.8, you know, I've just got this feeling. And I'm going to set the current to, I'll set it to 200 milliamps. So let's use the probe from the meter. Let's clip it on there, because then I can just probe this. Does that make sense? and then I'm not going to short anything. Yeah, it's pouring some current there when I do that. Let's just disconnect the power, reconnect the power again. Yeah, it's not doing anything. I'm kind of surprised at that. Let's increase it to 1.8 volts, because 1.2 might be wrong. And you've got quite a big difference between 1.8 volts and 1.2. Right, it's now set to 1.8 volts, 200 milliamp limit. Nothing. Let's disconnect the power. Nothing. Nothing getting hot, so yeah, that's made no difference at all. Let's just test the other one the same way. Hang on a minute. Yeah, it's pulling the current quite low. It's pulling the current down, actually, when I do that. I'm going to give it a tiny bit more current. Yeah, nothing's getting hot here. It's working. Let me show you. I put the current to 600 milliamps. Yeah, and I noticed when it was at 400, it was the current was okay, voltage was all right. Yeah, so it was drawing about, I don't know, 300 milliamps for a second or two, and then suddenly the current dropped. The current increased, and then the voltage dropped. And I thought, it's initializing. I think this is for the main chip. So I'll show you the current's 400 milliamps, 500 milliamps. 500 milliamps, 560 milliamps. I increased it to 600. Look, it's working. There we go. That's what it is. That's the issue with both of these. It's that little chip. Yeah, so that was a bit risky, you can argue, but the way I approached it was to gradually increase the voltage from 1.2 volts to 1.8, limit the current to 100, nothing getting hot, on 200, nothing getting hot, 400, nothing getting hot, but now I see a pattern. I see 1.8 volts staying at 1.8 volts for a few seconds, oh, it plummets. Hang on a minute, maybe it's booting. Yeah, let's go to 600 milliamps on the current. Bang, it works. Obviously be very careful when you're probing voltages onto things like this. I'll try it again now. 300 milliamps, 400 milliamps, 500 milliamps, and then boom, 600 milliamps, TV's on 720p. So there you go. And I think that this little thing here can provide, it might be up to an amp. So there we go. That's the issue. Common source of failure on these. Let's test the other one, see if the other one works. I'll let Jamie know that I can fix these and send them both back to him. Because I've got one of these already, I don't want another one. Let's connect the, hang on, HDMI, yeah, there, connect that there, and let's just give it the same test if I can find my meter. Where's my meter probe gone now? I don't know what I've done with it. Oh, it's here. So we've got our 1.8 volts here ready, everything's good. I'll point it with the TV, hopefully this isn't going to go up in flames, and we'll probe onto there. Looking at the current, hang on. It's drawing a lot more current, this one. But it's on, look. Yeah, that one draws more current. But anyway, that works as well. There could still be another fault with this one, because this one draws more current, like 150 milliamps more current than the other one. It's not exactly the same though, is it? It isn't exactly the same. Everything looks a wee bit different on this one. So yeah, I'll go and order those now, but yeah, I think we've pretty much fixed both of those. I'm sure of it. There could be another fault somewhere else, you know, but, well, it stands to reason that's going to be the issue. I mean, what can you do with something like this? Well, you could maybe bodge something else on there. We know it seems to need 1.8. You know, there's an argument in my mind. Why isn't I got one of these on? But you see, these are going to be quite a lot noisier, maybe. Mind you, it's a low dropout, isn't it? But these types of regulators here might not provide as much current as this tiny little thing here. That's one thing, you know, these are rated up to an amp. Try and get one of these in an amp. You could just bodge a 3.3 volt regulator on, sorry, not a 3.3, a 1.8 volt regulator on there, it'd be less efficient than this one, would dump some heat into the board, but you may find it's more long lasting than a tiny piddling thing like that, generating high current, or providing high current, not really generating, you know, allowing more current. So, I don't know. I do have some 1.8 volt regulators. You could try and bodge one on there. I mean, the thing is, we know it's already drawing, you know, between 600 to 700 milliamps. This is the thing. And if this thing can produce an amp, yeah, you're 3/4 to its, you know, towards its capabilities, aren't you? So putting something beefier on there might be an idea, is the point. But, well, you can't really squeeze anything in there. There's not enough space. You could stick something on the underside, though, and just join a wire around to the wherever it goes, you know, the right side of here, maybe, to recreate that 1.8 volts in a beefier way. Right, so I'm going to have a go at reading this. You can see I've got this little test clip on the top here. You just squeeze it and it fits onto an SO8 IC like that. And it's going into an adapter here that I made up. I'll show you that in a minute. And I had to measure from the dip one to make sure that pin 1 was going to pin 1, etc. all the way around. Yeah, and it's all just wired right that for this test clip. Yeah, at this point here I used the T48, which was kindly donated by TRU. And I picked an equivalent chip type here, which seems to communicate okay. Some flash devices like this will work even if you choose the wrong type of chip. Other ones are a bit more fussy because the protocol changes. And you saw me clip the test clip on the top there, and I read it and reread it a few different times and saved that. Now, whether it's protected or not, you know, I could have got garbage back, I don't know. But I've got a dump of that. At some point I'll dump the other one as well, because I didn't do this on both devices, and it'd be interesting to compare them to see are they the same or not. And I also saved like the configuration settings. There's like another area of the chip that holds some of the configuration bits, if you like, and I saved those as well, just so that it would be configured the same way if I ever decided to reflash one of these, assuming the code is okay. And at this point here, you can see me reread it a few times, taking the clip off, putting it back on, reread it, verify. I did that 2 or 3 times there, just to make sure that I'd got a good, reliable read, because you can think you've read something properly and you haven't. Yeah, so you saw that dumped okay. The second time with the error was I disconnected it and reconnected it a second time. The first time I didn't get it aligned right, the third time it was aligned right and we got to verify. It's worth doing that with that type of chip, with this type of connector. You could even, what I should do really is compare to the other one. I'm not that interested in it. They might have subtly different firmwares. In any case, that worked really well. I didn't think that was going to work so well. Trying to clip onto the top of a little chip like that, you'd think that would be nigh on impossible to achieve, but wow, they clipped on really well. So yeah, I think that was a successful dump of that. Well, I'm convinced it was. It's not very clear. It looks like it says 25032, and then I thought, is it a Q? I tried a few different chips, like a 25P32. It wouldn't work. It said the ID's wrong, and then I scrolled further down the list and I found a Q, and I thought, oh, maybe it's a Q, maybe it's not a 0. And lo and behold, the ID matched and it dumped. So yeah, it's a 25Q32 used on this one. The other one's got a different chip, I think. It's you know, they're going to vary. It's going to be the same type of thing, working the same way. Yeah, so these things I made quite some time, you know, at back. And it's just a little, you know, a generic adapter here from different SOIC things to this, pin out on both sides. And it's nice because you can stick that into your programmer. And as I say, I just measured, you know, it's like this pin goes to the, you know, they go to the points where you expect the nearest pin on there. But then on this side here, I'm like, where's pin 1? Well, if you align the red wire here to pin 1, it goes to pin 1, and everything just transposes across. You know, the pins on one side go to the pins on one side, and the other side goes to the other side. So you've just got to make sure you get that the right way around before you actually connect it up with respect to your pin 1. Do some connectivity tests as I did. We used the T48 there from TRU, so huge thanks to TRU. I already had that didn't come from TRU, this did though, the T48. So it's an upgrade to the programmer I previously used. I offered the other one out at like a really cheap price of 25 quid or something, or 30 quid maybe, on my Discord, and it was snapped up by one of the guys on there, so that's gone to a good home. But the T48 is the replacement for the 68, what's it called? The TL866, basically, this is the better one. It just does some chips that the TL866 can't do. So thank you ever so much to TRU. Wouldn't be able to dump this without a programmer. And I'm not sure I've shown it before, but I've got some, these are some of the adapters that I use. And yeah, that one came in handy today. You can see I've got a few of these ones. I've got one with and without the pin there. This one is aimed at, you know, I'll solder things onto that if I need to, and I've got a few different ones of those. And the other type for SOIC chips and stuff. I also kindly got this from TRU as well. It's an adapter for 27C 800s, the 400s, the 160s, 322s. So I can do this with my Willem, but I've never been able to do this with. I wonder where that goes. Oh, that goes into the front of it, doesn't it? It's got on the side. It's got a connector on the side. So it's nice that I've got that, but it doesn't do 27C4096 chips, that one. So a couple of weeks later, the components have arrived. I'll show you them here, if you can see them. Yeah, TD6801T. I hope these don't vary in terms of what voltage they're supposed to be. Yeah, so we need to get that off. So let's just get a load of solder. I mean, I could have used hot air here. I think I'm going to be able to, I was going to say smush it off. It may get pushed in the wrong location, that's the problem. The problem is these pins here on this side. We'll try hot air if this doesn't work. Let's just see if I can smush it off, like, you know, heat it up, super hot. Yeah, you can see it moving a bit there. There we go. Hang on. Right, this is where I need my prodding tool. It's just stuck on that one pad now. I'm confident this is the issue because we fed voltage in here and it worked, didn't it? So, there we go. Obviously, the longer you heat pads that size, the more risk of damaging it. Use the braid. There is a bit of solder already on that, but let's just see if we can get onto those pads. And I may need to add some additional flux here because the capillary reaction doesn't work as well unless you've got flux. Oh my goodness. Yeah, if you get stuck, just stop. There we go. Oh my god, what am I stuck on here now? Oh, it's like a strand of it's sticking somewhere. Right, that'll do. So let's get one of those onto the board. It would be upside down, wouldn't it? I've talked about this before. When I position things on boards, it'll always be upside down. It hardly ever goes the right way up, I think. Yeah, there you go. It was upside down. So, what's to be? That way around. Of course, you could just, you know, fit it with hot air. That would have been easier. Just left the solder there and just remove the old one, put the new one on. Nice and quick and easy with hot air. Right. Yeah, I think that's okay. Right, let's clean it and test it. Try and mostly brush in the direction away from the thing, you know, to the edge of the board. I mean, is that first pin soldered on? No, it's not on. It's not on. Right. That would explain it entirely, wouldn't it? But let's just give it another go here. So if I get the power lead, get the power lead up, power on. Still not working. Oh, hang on. Yes, it is. It just takes ages to come on. It takes ages to come on now. I did put my finger over it just as I did that. So let's just try that again. Just see how long it takes to come on. I'm not touching it now. Hands are nowhere near the thing. Just to see, is it like 20 or 30 seconds? There we go. Hey! I think that's fixed. So we'll reassemble. Should we reassemble? Tell you what. Let me just get something to connect up. We'll connect up the TFMSX again. Let's just disconnect power while we move a few things around on here, because I'm, well, as usual, a bit short of bench space here. So we've got the Terrible Fire MSX from Stephen Leary. Let's connect. I'm going to video. I was going to connect it to the TV then, the routine. Let's connect it to this. Right, we're going to have the power there for that. And for the MSX, I've got an old phone lead here, which I repurposed. So let's connect the TFMSX power up here. Right, TFMSX is on. Power for this thing, which is struggling to reach, look. Oh god, and it's catching on the USB there. Oh, that's so annoying. Look at where the power's got to go. It's got to go where the SCART thing is. I'm going to have to disconnect that, plug the power in, then plug the SCART in. What a stupid design that is. Let's just see what happens. It's got a secondary fault, hasn't it? I think. Hang on. No, that's the MSX that's doing that. Bear in mind, it's not been used in a while, and I knocked the USB stick, didn't I? Let's try it again. That works. Fantastic. One thing I don't like about these is this. There should be a button on there to get rid of that. I'm going to have a look at the data sheet if I can find one. Yeah, you can see it's glitching a little bit there. I think it is, because we're getting the odd speckles and things coming across it. We'll see what the other one's like. Bear in mind, these HDMI rescaler things, upscalers, they're not that great. Seems solid there now. Yeah, I think as it warms up it's alright. Which is an interesting one, isn't it? Why is it better as it warms up? Yeah, it's alright now. Yeah, it's not bad. It gives a good picture. The issue is that box, you know, that on-screen display thing. You can't switch the bleeding thing off. And I wonder if we could do a mod to it to, I don't know, disable the on-screen display somehow. That's solid now. We were getting the odd, like, scan line or bits of noise and stuff appearing. That's gone. You can press the buttons on it. I think one of them changes, yeah, changes the what it converts it to there, doesn't it? This is NTSC now. Hang on, the input's NTSC. Yeah, that would make sense because I've got it set to 60 Hz. This MSX. You know, it's running the US ROM, I think, or the Japanese ROM. I forget which one. That's in 1920 by 1080. Look. Pressing it again. 800 to 600. Definitely doesn't look as vibrant in 800 or 600, does it? It looks better in the higher resolution. And the other button, what's the third button? Yeah, that's when you want to toggle to the HDMI import, because you can toggle between the two things with that button. So anyway, it seems to be working, doesn't it? It's interesting to me that the colour's not as good. And if I press that button again to change the resolution, 1024, let's go up again. I'm trying to find 720p. There we go, 720p. The colours look better. They look more vibrant. This here looks more reddy and orangey than it was at the lower resolutions. No, it looks far better. So that's an interesting one, isn't it? How is the colour depth seemingly improved based on the resolution you choose? I don't know. Anyway, very pleased. Let's switch the MSX off and try and disconnect this thing. I can reassemble that one and then we'll put the other one together. You know, replace the part on the other one. Do while you're inside one of these, really, to repair, is replace these caps. The peddling little, are they Chong? I think they are. I think they're Chong. Yeah, Chong or Cheng. Chong, I think. So you might want to replace those caps. It could do with better heat sinking and stuff. You could put a little heat sink on these things. It's a shame you can't get heat sink onto that, but that's so small. Try and find a heat sink to heat sink that. And ultimately, it might be about the quality of the power supply that killed us, actually. That could be the thing. But when these things are left plugged in, you know, it's easy to do, isn't it? Plugged in on the floor, under your bench, left for weeks and months, and you're like, oh my god, I left that on. Yeah, that's one thing that will kill them. So I don't remember which one of these enclosures. Well, it must be this one. Hang on. Yeah, because that's the thing for this, isn't it? They're identical anyway, but anyway, I can't honestly remember now if there were any. Yeah, there were 2 screws with them. 2 screws holding the board in. I'm so pleased though, because all the things Jamie has sent me, you'll see. I got an OSSC, if you've not already seen that, post link top right. And that's a sick puppy, and then 2 of these, and I've fixed them all. So I did ask Jamie if he wanted, I'm just wondering now, black screws, yeah, the same screws, if he wanted these back, because I would just send them back to him free of charge. And he was like, no, it's alright, I want you to keep them, you use them, because he's got other things now, including an OSSC. So yeah, I'm puzzled why there are. Oh, that's right, there's 3 screws to hold the board in, and then each one of the lids has a screw. It's mysterious to me why you would have 3 screws to hold the board in as well. What's wrong with 4? And yeah, clean the inside of that, I guess. Has it got a dint in it? Yeah, it's got a dint in it, look. So what I'll do with that is hammer it, I think. Let's just try that. Let's just put it on here and hammer it. Yeah, it's not often I hammer things, but when you've got big dints like that, hammering it is probably the best way to go. Just hit it at the point of the dint. It's mostly gone. It's still protruding a bit there. That's it. You'd have to look pretty hard to notice that. Yeah, it's gone. You can see the impact marks there. Anyway, and I now can't remember which one it is that I've just fixed. It's this one, isn't it? It's this one. I've got a screw loose on there. Where did that come from? Hang on, there's one of the screws popped out. One of the screws popped out. The screw wasn't in. How was the screw not in? It goes under there, doesn't it? It goes like that. Yeah, and then you try and massage it that way. There we go. It's still dirty there, look. It's going to need to clean with something a bit more substantial. It's like it needs baking soda on it or something, I don't know. It's got an X on it. X indicates bad. This is the one with the chip ground off. What the hell? Oh, you know, one of the guys in my Discord made me laugh before. Someone was doing something like this with a giant soldering iron. He was like, Gadget was doing that earlier. Well, I wasn't, but I am now. That's exactly what he was pointing out this morning. And I was almost insulted. I'm like, I don't do soldering like that. Well, I just did. I just did the world's worst soldering. Or desoldering. Sure, those things aren't getting hot. Let's just try it again here. No, it's working. It's working. I'm imagining things. When I felt that, I thought it was getting hot. I don't think it was. Because it's alright, it's working. You can see that there. It's weird, it was like a psychosomatic thing where I thought it was getting hot. And I thought it burned my finger, and now I touch my finger's not burned at all. That was like, I imagined it. I imagined the whole thing. Power to the MSX. Yeah, we had exactly the same thing as the other one. And I remember seeing this on mine. Mine does that. So, for whatever reason, when you first power them on with some RGB inputs, you get these little speckly things that shoot across. Like that. It might be the on-screen display that somehow interferes, I don't know. Because it seemed to disappear before, didn't it? After that went away, I think those issues stopped. Yeah, picture's solid now. I think before I reassemble this one, I'm just going to measure the voltage going to the inductor there. What I mean is, this little thing here, I'd like to just measure what voltage is going to it, because the other option, you might want to fit a beefier regulator, the 1.8 volts, assuming it's 1.8 volts, so I'm just going to measure that side of that there. 1.3, and that side's 1.282. That's interesting. Yeah, measuring from one of the ground points on the board. Let's just see what we've got. So I think we've got 5 volts coming in, don't we, here? Can't see where I am. 5 volts in, this side here. 0.6 of a volt. Sound went out then, didn't it? It makes me think this is to do with sound, I don't know. 1.3. And yeah, just changing to the other hand here, just try and do this carefully. 5 volts, middle pin. Nothing, or low. So, is that outputting about 1.3 volts? It's a really strange voltage, isn't it? Yeah, so I'll retest these for a longer period of time. Just feeling the top of that. Yeah, it's not even warm. So, it is a bit strange to me that 1.3 volts is a thing there. It's like, why do we need 1.3? It could be for the silicon image chip there. That's my guess. My guess is it was working all along, but we had no video output. We had no video output because that didn't have 1.3 volts or something like that. It could be 1.2, but it's, you know, it's slightly higher than you might expect. 1.2 makes more sense to me. Yeah, it's not too dirty, the inside of that. And by the way, on these things, if you don't like the aspect ratio, you can just change it on your TV to 4:3, and the aspect ratio is now correct. That looks really good. Yeah, for the 30 quid or so these things cost, they give out a pretty damn good picture, really. It's just that initial, you know, the lines we saw when you first switch it on, and the on-screen display. So I'll go see if I can find a data sheet, see is there any way we can actually disable the on-screen display, because you know what, it's irritating, that on-screen display, if you ask me. It'd really be better if it was switchable, switch it on and off. So let's have a go with some IPA on the top of that one. God, that one's filthy. I thought that was sun faded. You can see it's not, it's just dust and dirt. It's probably like 3 or 4 years of dust and dirt. Hard to believe how bad that was. Yeah, black things like this, I've described this before. Xboxes are renowned for doing this. That when you wipe them with IPA, they go sort of fadedy or, you know, a bit odd, you know, discoloured. And the exact same thing is fixed on Xboxes, the original black ones, you know, OG Xboxes. Silicon spray like this, a little bit, and just wipe that around, and it soaks into the surface plastic / paint. And makes it look good as new. And what doesn't happen is when it dries out, yeah, you lose the glossiness when this type of thing dries out. Yeah, it's not as wet looking and shiny looking. But what it doesn't, the streaks don't come back. The streaks do not come back. I've cleaned a number of Xboxes that way. My one I've got in a storage crate there to do a video on at some point soon is one of those, and even though it's not been wiped like that in years, it looks good as new. There we go, hopefully you found that interesting. Yeah, so thanks to Jamie Morgan for sending those. Do check out the links down below to Jamie's channel. He does lots of amazing gameplays on Amiga games, C64, Mega Drive, PlayStation, etc. I'll catch you in the next video.